to go over that one more time. So second trace, number 3, left bound is on the left side of the vertex, right bound, right side of the vertex. It says guess, enter once more, so -2, -10. Axis of symmetry is the x value of the vertex. That's all. Okay? Question?
So what happens if you do the left bound on the right side?
You'll get an error message. Okay? Good question. So did it have a min or a max? It has a min. You know that because A is positive. So if A is greater than 0, the graph will have a minimum. Okay? And then your calculator or the solution manual likes to only give the y value for the minimum. And then it doesn't say domain, but we're going to say domain. What's domain always? X equals, don't forget x equals, that's that annoying half point off. X equals all real numbers and range is y. So y and -10, is it less or greater? Right? Are the y values bigger or smaller than this dot right here? Y values increase, so greater than or equal to. So that's how you solve this on the graphing calculator. Don't make it any harder than that. Yeah, we're going to go, yeah, that is standard form, ax squared plus bx plus c. Okay, only thing I want from this whole slide is this right here. Y-intercept is 0c. You don't need any of this other stuff. So y-intercept is 0c. Now we're going to do this by hand. So graphing it by hand. So number 1 is x equals -b over 2a. This gets us the x value of the vertex. And the axis of symmetry. So what, right, standard form ax squared plus bx plus c, what's a in this equation? What's a? What number's in front of the x squared? 1. So a is 1. What's b? 2c. Okay, so we're going to plug in -b over 2a. So b is 2, so I have -2 over 2. A is 1, right? So we're plugging in that 1. So we get -2 over +2 or -1, right? That's what x equals. So we're just going to talk about graphing that next, because that messes people up. Oops, that's not what I meant to do. So if we just go back, x equals -1, I'm going to hold off on that for now. Got our coordinate plane. Now we're going to plug in for step 2. Plug x in to find y. Into the original equation to find y. So our original equation is y equals x squared plus 2x plus 3. And we're going to plug that -1 we got right here for this x and right here for this x. So we get y equals -1, don't forget to use parentheses, squared, plus 2 times negative 1 plus 3. You can throw that in your calculator for safety. You get 1 minus 2 plus 3. So y equals 4 minus 2, which is 2. So our vertex is negative 1 comma 2. So we did negative b over 2a to get the x value of the vertex. Plug that into the original equation to get the y value of the vertex. And now I'm going to make that ordered pair on my next page here. Negative 1, 2. So right away I can draw in the axis of symmetry because it just cuts that vertex right in half, right? Now if I get wherever my y-intercept is, does anyone remember what it was? Y-intercept, what's C? You can, C is 3, so I have an ordered pair at 0, 3. Right, so here's my vertex, there's my y-intercept. So I know if I'm 1 away from the axis of symmetry, I just go 1 away on this side, and then I can graph my parabola. That's all you got to do. Okay, so from the y-intercept right here, I went 1 over to the axis of symmetry, 1 more over, and then you can draw your parabola. And right looks like a U if it doesn't look like a U. Okay? So get the x value of the vertex, negative b over 2a. Plug it in to get y. Draw your axis of symmetry. Get the y-intercept. And just move over from the axis of symmetry. That's all you got to do. Okay. Write this one down. We're going to go from standard to vertex form now. Standard form is ax squared plus bx plus c. A, b, and c have to be integers. What's that mean? What's an integer? Whole number, no decimals or fractions. Negatives, 0 or positive numbers, no decimals or fractions. So a, b, and c have to be integers. Oh, geez. So first step, we're going to do negative b over 2a again. So up here, a is 2, b is 10, and c is 7. So I have negative 10 over 2 times 2, which equals negative 10 fourths, which equals negative 5 halves, which equals negative 2.5. So we're trying to get from standard to vertex form, so obviously we need a vertex. To get the x value of the vertex, you do negative b over 2a. To get the y value of the vertex, you plug that in to the original equation. So y equals 2, I'm just going to write the original equation again, plus 10x plus 7. And we're going to plug that negative 2.5 in right here and here. So we get y equals 2 times negative 2.5 squared plus 10 times negative 2.5 plus 7, like that. Yeah? Just whatever in our problem, it was like this. 2x squared plus 10x plus 7. Yeah, so it makes it clear then, right? So if you didn't get how to get the a, b, and c, right? 2's in front of the x squared, a's in front of the x squared. 10's in front of the x, 10's the b, and 7 is the c. We're going to plug this into the graphing calculator, make sure we don't screw it up. I've got it right there. So you get negative 5.5. So y equals negative 5.5. What's the vertex? What's the vertex? What's the x value of the vertex? Negative 2.5, comma, negative 5.5. So now we can go to vertex form. So this is going to be the h, and this is going to be the k in vertex form. Thank you. And the a is the same. This a is the same as that a. So we can just plug a 2 in for that a. So I'm just going to rewrite vertex form here. Y equals a parenthesis x minus h squared plus k. So y equals, in our case, a was 2. Opposite sign in the parentheses, so plus 2.5 squared minus 5.5. So the a's are the same in standard and vertex form. That's important to remember. Okay. We only have one more. We're not doing that one. We're doing this one, though. Write that equation down. Give it a little sketch of the bridge. You want this distance here with the 516. We're going to figure out the height and the length of the bridge from where it hits the grassy area down here, the tree-lined area there. Yes. Like a bridge question. This is a good one to write down and write on quiz and test. Okay, it says the New River Gorge Bridge in West Virginia is the world's largest steel single arch bridge. You can model the arch with the function, that thing, where x and y are in feet. How high above the river is the arch? How long is this section of bridge above the arch? So you're going to plug this equation into y equals, into the y1, so you can do that. And you can start trying to figure out where the window goes if you'd like, because that's the tricky part. So it's negative 0.30498 x squared. Okay, make sure you double check your calculator, you get that in correctly. And then you can hit zoom 6 and see what it looks like. And it should virtually look like a straight line. So is this parabola right side up or upside down? Is A negative or positive? A is negative, so this is going to be an arch, right? It's going to look like the bridge. So what do I need to increase? Y max and X max. I'm going to do X max first. I did it last period, but we're going to go 2,000, and then we'll go 500 on Y max. So 2,000 on X max, 500 on Y max, and then it's all purdy. So I'll show you again in case you didn't get that. 2,000 X max, 500 Y max. So, looking at this graph, we want to know how tall this is. What am I looking for, X or Y? I'm looking for the Y value of the vertex to see how tall it is. And the X value of the vertex will just give me half the distance, right? Then I need to double it to get the entire distance. So second trace, is this a max or a min? second trace max. And I want to be on the left side of the vertex, right side of the vertex, and you should get 850 and 360.15. Okay. Does anyone need help getting that? Yeah. We look at our bridge over here, 850 is the x value. That goes from here to here. Oop. Right, 850 is from here to here, so it's this section from here to here, also 850. So the total distance from where the bridge meets the land to where the bridge, 1700. That's the total distance underneath the bridge here, 1700. And then top to bottom, that's the 850. So we have to add that 850 to the 516. So this is length of the bridge. And then height, this is height to the water, is 850 plus the 516 we already had. Right? That's to the water. We'll say to the river because it's a river. Okay? So 1,700 feet long and 1,300 feet to the river. Okay? So your homework is 9 through 29, every other odd. Here's how every other odd works. 9, 11, 13, 15, 19, 21, like that. So if I'm going every other odd, I skip 11, do 13, skip 15, do 19, skip 21, like that. Okay? Ready, set, go.